In this video, we will be looking at polynomial expressions. We're going to begin by adding and subtracting polynomials. First up, we have x squared plus 2x minus 4 plus negative 4x plus 8. I'm going to start by getting rid of my parentheses, and the way I can do that is by putting an invisible 1 in front of each of my parentheses and then distribute that invisible 1 through the parentheses. So if I do that, I'm going to have x squared plus 2x minus 4 minus 4x plus 8. Then I just need to combine my like terms, and I will have x squared, 2x minus 4x gives me a negative 2x, and negative 4 plus 8 is a positive 4. So we get x squared minus 2x plus 4. I'm going to do the next one the same way. This time I'm just subtracting the polynomials rather than adding them. So I'm going to have my x squared plus 2x minus 4, but now I have to be careful because I'm distributing a negative 1 through the parentheses. Negative 1 times negative 4x is a positive 4x, and negative 1 times a positive 8 is a negative 8. If I combine my like terms, I'm going to have x squared 2x plus 4x is a positive 6x, and negative 4 minus 8 is a negative 12. So we get x squared plus 6x minus 12. So we have our addition and subtraction. Next up is multiplication. When it comes to multiplying polynomials, the idea of distributing still applies like it did when we were distributing constants through parentheses. So first up, we're looking at a negative 3x times x squared minus 5. I am going to distribute that negative 3x through the parentheses. So first up, I'll have negative 3x times x squared, that's a negative 3x cubed. And then a negative 3x times a negative 5 is a positive 15x. So we just get negative 3x cubed plus 15x. In the next one, I'm multiplying two binomials. They're binomials because they have two terms each. I can do this one of two ways. I can think of it as distributing, which is totally fine, or I can FOIL, if that's something that you're familiar with. Either way, we're going to be multiplying the same way, so it doesn't matter which way you think of it. So I'm going to have 2y times a negative 4y is a negative 8y squared. 2y times a positive 8 is a positive 16y. Negative 4 times negative 4y is another positive 16y. And negative 4 times a positive 8 is a negative 32. If I combine my like terms, that gives me a negative 8y squared plus 32y minus 32. Another method that several of my students have seen before is called the box method, and that's another way we can multiply these. Because they're both binomials, I'm going to make a box that's 2 by 2 so that there's room for two terms on each side. We have a 2y and a negative 4. We have a negative 4y and a positive 8. Where the two intersect, I'm going to multiply. So 2y times a negative 4y is a negative 8y squared. Negative 4 times a negative 4y is a positive 16y. 2y times 8 is another positive 16y. And negative 4 times negative 8 is a negative 32. You'll notice these are all the same terms that we got before. This is just a more visual way of looking at it. If you like using this, please be my guest. I will never turn you down for using that. But you don't have to. Next up, we're looking at 2x minus 3 quantity squared. I need to remember that when something is squared, that means that it's multiplied by itself. So another way I can write this is 2x minus 3 times 2x minus 3. Then I can FOIL this out. 2x times 2x is a 4x squared. 2x times a negative 3 is a negative 6x. Negative 3 times positive 2x is another negative 6x. And negative 3 times negative 3 is a positive 9. Combining my like terms, that gives us 4x squared minus 12x plus 9. In this last one, we have p minus 4 times p squared minus 2p minus 7. This is a time when the box method can really come in handy so that you don't miss any terms. You would just have to make sure that you have a 3 by 2 for your boxes. I'm still going to think of it as distributing or foiling, but extended foiling, so foiling, if you will. So what I need to do is make sure each term in the first each term in the first polynomial gets multiplied by each of the terms in the second polynomial. So first up we have p times p squared, that's p cubed. P times a negative 2p is a negative 2p squared. P times negative 7 is a negative 7p. Now I have my negative 4. Negative 4 times p squared is a negative 4p squared. Negative 4 times negative 2p is a positive 8p, and negative 4 times negative 7 is a positive 28. To get my final answer, I need to combine my like terms. So I have a p cubed, negative 2p squared, and a negative 4p squared gives me a negative 6p squared. I have a negative 7p and a positive 8p, which gives me just plus p, and then the plus 28 out back. And that's our multiplication. So we have addition, subtraction, multiplication. What comes next? Division. When we are dividing polynomials, we can take each term in the numerator and divide it by the denominator. So we're just breaking up the terms to make them easier to work with. So for our first one, we have a 12x cubed minus 2x squared plus 6 over 2. I'm going to just start by breaking up each of these terms so that they're easier to work with. So we have a 12x cubed over 2 minus 2x squared over 2 plus 6 over 2. We're allowed to do this anytime we have addition and subtraction in our numerator to break them all up like this. So my first term is going to become a 6x cubed minus sign x squared plus 3. So we're just dividing term by term rather than thinking of it as something more complex. I'm going to do the same thing for the second one. We have a 12x cubed over 4x minus 2x squared over 4x plus 6 over 4x. So 12 over 4 reduces to 3, x cubed over x. One of the factors of x divides out, so we're still left with an x squared, minus 2 over 4 reduces to 1/2, and then x squared over x. One factor of x divides out, but we still have 1 in the numerator. So if we have 1x over 2, that's okay, but if you prefer, you can just write it as x over 2. Plus 6 over 4 reduces to 3 over 2, and then we have an x in the denominator. There are no x's to divide it out with this time. This last one, we have 6 times 15w minus 10 plus 20 divided by 5 plus 8w minus 11. I'm going to start by distributing my 6 through the parentheses so we can really see what we're working with. So 6 times 15w is 90w. 6 times negative 10 is a negative 60. Plus 20 all over 5 plus 8w minus 11. I can combine my negative 6 and my positive 20 so that I have 90w minus 40 over 5 plus 8w minus 11. Now I can break this up into my two terms. So I have my 90w over 5 minus 40 over 5. And we still have our plus 8w minus 11. 90w divided by 5 simplifies to 18w. 40 divided by 5 is 8. So we have minus 8 plus 8w minus 11. 18w plus another 8w is 26w. And negative 8 minus 11 is a negative 19. So this simplifies to 26w minus 19. So we've now looked at adding, subtracting, multiplying, and dividing polynomials. We're going to work now on doing the backwards steps of multiplying these polynomials. What's nice about this is it's going to help us solve equations in the future. What these steps are called are factoring. The first step with factoring, always, every single time, is factor out the greatest common factor. So every single time you are asked to factor, start by looking for a greatest common factor. If the greatest common factor is greater than 1, then we're going to factor it out. I'm going to show you the long way to find the greatest common factor, and then once you become familiar with it and comfortable with it, you'll be able to start doing it in your head. So first up, we're looking at 2x squared plus 4x. 2x squared, if I break that down into all of its pieces, that's 2 times x times x. 4x can be broken down. Well, 4 itself can be broken down into 2 times 2. So this is 2 times 2 times x. That's how it all breaks down. We're looking for the greatest common factor, so we want to find what do these have in common. They both have a factor of 2. They both have a factor of x. So I can factor out a 2x. That will come out front of my expression. And then what's left over from each term is going to be what stays inside parentheses. So we have an x and a 2. It'll be x, there was a plus sign, 2. So what we just did was we factored out a 2x because that was the greatest thing these two terms have in common. They both had 2 as a factor, they both had x as a factor, so I factored them out front. And that left me with x plus 2 in parentheses. When you're factoring, you can always check your answer by multiplying back through. 2x times x is 2x squared. 2x times 2 is 4x. So we know we got the right answer. Next up, we're looking at x to the 6th minus 24x to the 4th. So let's start by figuring out what all we have. X to the 6th, that's just x times x times x times x times x times x. Negative 24x to the 4th, well, let's figure out what 24 breaks down into. 24 is 6 times 4, 6 is 2 times 3, 4 is 2 times 2. So 24x to the 4th is equal to, I have 3 factors of 2, 1, 2, 3, a factor of 3, and then x to the 4th is x times x times x times x. Starting with what they have in common, they both have 4 factors of x. X times x times x times x, that's x to the 4th. So I can factor in x to the 4th out front. In parentheses is going to be what's left over. We have an x times x, which is x squared. Then there's a minus sign. We have 2 times 2 times 2 times 3, that's 24. So we have x squared minus 24 left in parentheses. For the last one, we're looking at 3a to the 4th b to the 7th minus 6a cubed b cubed plus 12ab to the 5th. This one I'm going to kind of do by looking at it rather than trying to find all the pieces, because I know looking at the coefficients, 3, 6, and 12, those are all divisible by 3. So I'm going to factor out a 3. Now I'm going to look at the a's. My first term has 4 factors of a. My second term has 3 factors of a. My third term has one factor of a. So the most that all three have in common is just the 1. And then if I look at my b's, I have 7 factors of b in my first term, 3 factors of b in my second term, 5 factors of b in my third term. So I can pull out 3 of them. No more, because the middle term only has 3 to give. So in parentheses, I need what's left over. So I pulled out a 3. I pulled out 1 factor of a, so I still have 3 factors left. I pulled out 3 factors of b, so I have 4 factors left. So we're looking at 3ab cubed times a cubed b to the 4th. Then minus sign, so we're going to put that in there. 6 divided by 3 is 2. We pulled out one of the a's, so we have 2 left. And we pulled out all of the b's, so we don't have to worry about those. Then we have a plus sign. 12 divided by 3 is 4. We pulled out the a. We have 2 factors of b left. So this factors into 3ab cubed times a cubed b to the 4th minus 2a squared plus 4b squared. So factoring out the greatest common factor, that is always going to be our first step, every single time we are asked to factor. Another type of factoring we need to look at is factoring by grouping. We use factoring by grouping when we have 4 terms. So you'll notice that I have 4 terms here. I'm going to break them into 2 groups of 2 by putting a dotted line after my second term. Then I have 2 groups. If I look at the first set, 2x squared plus 5x, I'm going to factor out the greatest common factor between those two. Between a 2x squared and a 5x, they have an x in common, which leaves me in parentheses with 2x plus 5. Now I'm going to look at my second set, 4x plus 10. They have a 2 in common, and if I factor out a 2, I'm left with 2x plus 5. When I factored out the 2, I factored out a positive 2. So you'll see that I now have x times 2x plus 5 plus 2 times 2x plus 5. These 2x plus 5s are expressions that they now have in common. So between these two, they have a 2x plus 5 in common that I can pull out front. And after I factor out a 2x plus 5, so I've taken care of those terms, what's left over is x plus 2. And that's how we factor by grouping. This one's a little weird to do for a little while, but once we get to the next type of factoring, then we'll see how this can be useful as well. The next one is very similar, but you'll notice we have different signs on the 4x and the 10. So I'm still going to break it down into 2 groups of 2. Out of the 2x squared plus 5x, I can still factor out an x, leaving me with 2x plus 5. In the second group, I can factor out a 2, which would leave me with negative 2x minus 5. The problem is these now don't match. They have to match for me to be able to do like I did in the last one. So what do I need to do to make these match? Well, they're really, really close. The signs on this second set are just opposite of what they need to be. So if I factor out a negative 2, that will change the signs on the inside. So we have 2x plus 5. So we now have that 2x plus 5 in common. And if we factor out the 2x plus 5, then what's left over is x minus 2. If you're ever stuck trying to figure out whether you should factor out a negative or not, look at the very first sign after your dotted line. That sign right there, it's negative, so I'm going to factor out a negative. Last time it was positive, so I factored out a positive. That's going to be your quick way of knowing whether to factor out a positive or a negative. So far we have greatest common factors, and we have factoring by grouping. Next we're going to look at trinomials. which are 3 terms. The first type of trinomials we're going to look at are trinomials such that a equals 1. Now let me talk about what that means. So something we will get in the habit of doing very, very soon is having trinomials that look like ax squared plus bx plus c. So there will be a squared term, an x term, and a constant. A is going to be the coefficient on the x squared. So if a is 1, well, 1x squared, we can just write it as x squared. So if a is equal to 1, then life gets really good for us. I'm going to show you a way of factoring trinomials that will work for us. If you can do them in your head, that's totally fine. But I just want a way to practice. So when we're factoring binomials, what we're going to want to do is take our a value times our c value. So a is 1 because we just have an x squared. And our c value, that's the constant, that's 10. 1 times 10, that's equal to 10. So we're taking our a value times our c value. Whatever I get for a times c, so in this case 10, I'm going to make a t-chart. In that t-chart, I'm going to list the factor pairs of 10. So the different ways I can multiply and get 10. I could multiply 1 and 10, 2 and 5, negative 1 and negative 10, or negative 2 and negative 5. One of these pairs is going to be better than the others. The pair that I want, when I add them together, I should get my b value, which is a positive 7. So the pair that when I add them up gives me 7 is the 2 and 5. Oops. If your a value is equal to 1, like it is for us right now, we can set up 2 sets of parentheses with x's out front, and then we just take these two numbers and place them after the x's. We had a positive 2 and a positive 5. So this factors into x plus 2 times x plus 5. As I mentioned when we were doing greatest common factors, we can always check our answers by multiplying it back out. So we have x times x is x squared. X times 5 is a positive 5x. 2 times x is a positive 2x. And 2 times 5 is a positive 10. If I combine my like terms, I get back to the x squared plus 7x plus 10. Let's try another one. This time we have x squared minus x minus 12. So I'm going to start by finding my a, b, and c values. A is the coefficient on my x squared. Since it's just an x squared, that means my a value is 1. My b is the coefficient on the x. It's a negative x, so that coefficient is a negative 1. My c is my constant, which is negative 12. So I need to take a times c, which is 1 times negative 12, which is a negative 12. I need to set up my t-chart based on negative 12. So we put the negative 12 on top. The different ways we can multiply and get negative 12 would be 1 and negative 12, 2 and negative 6, 3 and negative 4, 4 and negative 3, 6 and negative 2, or 12 and negative 1. We want the pair that when we add them up, we get a negative 1. That's going to be the 3 and negative 4. Since our a value is 1, we can just set up our parentheses with x's out front, and then we just plug in our numbers. We have a positive 3 and a negative 4. So x plus 3 times x minus 4. So now that we have a couple of these different methods under our belt, we are going to practice starting putting them together. So what we should always check for is that greatest common factor that we mentioned at the very beginning. If the greatest common factor is greater than 1, we're going to want to factor it out. So in this example, we have 3x squared plus 12x minus 36, I recognize that all three of those are divisible by 3. So I can factor a 3 out from this expression, and that will leave me with x squared plus 4x minus 12. So now that I have the greatest common factor out, I need to check to see if this trinomial here continues to factor further. So I'm going to leave my 3 out front and see what I can do with x squared plus 4x minus 12. So if I take my a value, which is 1, times my c value, which is negative 12, I'm going to have my t-chart based on negative 12, which I had last time. So I'm not going to worry about writing all the pairs. I just need to find the pair that I want. I'm thinking 2 and 6 are going to be important. Since I'm looking for a positive 4, I'm going to want a negative 2 and a positive 6. So this is going to factor into x minus 2 times x plus 6. But you can't forget that we were not just looking to factor the x squared plus 4x minus 12. We still had that 3 out front. Don't forget him, he's important. So we leave our 3 out front, and then we can just copy over our x minus 2 times x plus 6. Now we're going to try another one. So first, we need to check for our greatest common factor. We're looking at x cubed plus 5x squared plus 6x. It looks like they all have an x, so let me factor an x out front first. In parentheses, that will leave me with x squared plus 5x plus 6. So I'm going to take a look at this trinomial. My x squared plus 5x plus 6. I need to see if that factors further. My a value, 1, times my c value, 6. That's 6. The ways to multiply and get 6 are 1 and 6, 2 and 3, negative 1 and negative 6, negative 2 and negative 3. I want the pair when I add them up, I get a positive 5, so that will be the 2 and 3. So it factors into x plus 2 times x plus 3. But again, we have to remember, we factored out an x already. We need to make sure that x stays in front. So we have x times x plus 2 times x plus 3. And that's what we got. So now we've kind of put together some different ideas, but one drawback we have is that we only know how to factor trinomials that have an a value of 1. So now we're going to start looking at, well, what if the a value isn't 1? What can we do then? So factoring in the leading coefficient isn't 1. So if we're looking at 5x squared plus 7x minus 6, we can factor by grouping, which is also known as the AC method. So we're going to multiply a times c, like we've been doing. We're going to find the factors of a times c that add to give us b. So that's what we've been doing so far. This is when things get different. We're going to split the middle term into those factors. So we're going to take this middle term here and break it into 2 things added together. That's going to make it so we have 4 terms. Then we can factor by grouping like we did earlier. So let's see what that looks like. We want to factor 5x squared plus 7x minus 6. So first off, we need to ask ourselves, is there a greatest common factor that I need to be worried about? It doesn't look like all 3 of them have x's, so we don't have to worry about that. 5, 7, and 6, the only factors they have in common, positive at least, is just 1. So if our greatest common factor is 1, we don't worry about it. Then we move into our factoring by grouping or the AC method. So I need to find my a value times my c value. Well, my a value is 5 because it's the coefficient on x squared. My b value is 7 because it's the coefficient on x. And my c value is a -6 because that's my constant. So if I take my a times c, that's 5 times the -6, which is a -30. So I'm going to set up my t-chart based on a -30. We could do 1 times -30, 2 times -15, 3 times -10, 5 times -6, 6 times -5, 10 times -3. Oh, that's the one I want, so I'm going to stop. 10 times -3 is the -30, but if I add them together, I get the +7 that I'm looking for. This is when things go different. Since our a value is not 1, we need to take our middle term and split it into 2. That 7x is going to become a 10x and a -3x. So we have 10x minus 3x, and that was a positive 10x. Our x squared term is going to come down, so we have 5x squared, and our -6 constant term comes down. The reason why this works is because if you do 10x minus 3x, it gives us the 7x. So the only thing we've done is made it slightly more complicated, but we know how to handle this now. Because now that I have 4 terms, I can break it down the middle. Between a 5x squared and a 10x, I can factor out a 5x, which leaves me with x plus 2 in parentheses. The first sign after the dotted line is negative, so I know I'm going to factor out a negative. 3x and 6 have a 3 in common. And if I factor out a -3, I'm left with x plus 2. It's going to be plus because remember we factored out that negative. If we factor out the negative, we're left with a plus. Now they have the x plus 2's in common. And if I factor out the x plus 2's, what I'm left with is 5x minus 3. And that's our factoring by grouping, which we use when our a value is not equal to 1. Let's try another one. 3x squared plus 17x plus 20. First, we need to check for a greatest common factor. It doesn't look like we have a greatest common factor other than 1. So let's start our factoring by grouping. Our a value is 3. Our b value is 17. Our c value is 20. A times c is 3 times 20, which is 60. So we need to make a t-chart based on 60. We could do 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and that's the one I want. I want 5 times 12. Be really careful. A lot of people are going to want to stop at 3 and 20, but if you add 3 and 20, you get 23. If this were a -60, this would be a whole other story. But for positive 60, we need either 2 positives or 2 negatives. So in this case, we want the 5 and 12 because they add to give us 17. So now I get to break my middle term into 2 terms. So that 17x is going to break into 5x and 12x, and that was a positive 5x. I need to bring down my 3x squared and my positive 20. Once upon a time, I had a student tell me that this was also called the pants method because this looks like a pair of pants with the way the lines are drawn. It's weird, but whatever. We break it down the middle. Between 3x squared and 5x, I can factor out an x, which leaves me with 3x plus 5. Between a 12x and a 20, the greatest common factor is a 4. So if I factor out 4, I have 3x plus 5. So we have the 3x plus 5 in common. And if we factor out the 3x plus 5, that leaves us with x plus 4. Now you might be asking yourself, well, what if I wrote 12x first and then the 5x? What would happen? Well, let's check it. Let's see what would happen. So what if we put the 12x first and then the 5x? We'd still break it up. Between the 3x squared and the 12x, we have a 3x in common, which would leave us with x plus 4. Between the 5x and the 20, we have a 5 in common, which leaves us with x plus 4, and you might see it already. They have the x plus 4s in common. And if I factor out the x plus 4s, that leaves us with 3x plus 5. So we get the same two factors. You might be worried because they're in a different order, but math is pretty wonderful in the sense that when we're working with expressions like this, order doesn't matter because we have the commutative property of multiplication, which just says 2 times 3 is the same thing as 3 times 2. So as long as you have both of these expressions in parentheses, it doesn't matter which comes first and which comes second. We're going to try one more factoring by grouping. We have a 75q squared plus 20q minus 20. Looking at these, I can tell they're all divisible by 5. So let's see what happens if I factor out a 5. If I factor a 5 out front, that leaves me in parentheses with 15q plus 4q minus 4. So now I want to see if this 15q plus 4q minus 4 factors any further. So I'm going to take this off to the side and deal with it on its own. So we have 15q squared plus 4q minus 4. So I need to take my a times my c. That's 15 times a negative 4. 15 times a negative 4, that's a negative 60. So we need all the ways to multiply and get a negative 60. We could have a 1 times a negative 60, 2 times a negative 30, 3 times a negative 20, 4 times a negative 15, 5 times a negative 12, 6 times a negative 10, 10 times a negative 6, and that's the one I want. 10 times negative 6. So I'm going to take my 4q and break it into a positive 10q and a negative 6q. I can bring down my 15q squared and my negative 4. Now that I have 4 terms, I break them into 2 groups of 2. Between my 15q squared and my 10q, I can factor out a 5q, which leaves me in parentheses with 3q plus 2. I need to factor out a negative because that's the first sign after the dotted line. And 6q and 4 have a 2 in common, which would leave me with 3q plus 2. Yay, they match. Happiness. So they have a 3q plus 2 in common. And if I factor out that 3q plus 2, I'm left with 5q minus 2. But remember, this is just the 15q squared plus 4q minus 4. We factored out a 5 out front in the very beginning. We can't forget that 5. So the final answer we're looking for is the 5 out front times our 3q plus 2 times 5q minus 2. That's the answer we're looking for. Okay, so now we have greatest common factor, factoring by grouping. We did the 4 terms. We did trinomials where a was 1 Now we've done trinomials where a is not equal to 1. Now we're going to look at polynomials that have two terms, which are called binomials. And the binomials that we're going to factor are differences of squares. So we say x squared minus a squared is a special form of a polynomial called a difference of squares because it's something squared minus something squared. If it makes you more comfortable, you can think of it as x squared plus 0x minus a squared, and then we can factor it. But there's a shortcut for factoring differences of squares. If we have x squared minus a squared, it factors into x plus a times x minus a. So I'm going to show you a way that we can think about this that'll hopefully make this a little bit easier. So first up we have x squared minus 4. I want to write it as something squared minus something squared. Well, x squared is just x squared. 4 is 2 squared. So that means this is going to factor into what's in the first parentheses, x, plus the second parentheses, 2, times first parentheses, x, minus second parentheses, 2. As always, we can FOIL this out to check to make sure we have the right answer. X times x is x squared. X times negative 2 is a negative 2x. Positive 2 times x is a positive 2x. And 2 times negative 2 is a negative 4. So you'll notice our x terms cancel out and we're left with x squared minus 4. So in the next example, 81x squared minus 49, I want to write it as something squared minus something squared. Well, to write 81 as something squared, that's 9 squared. And to get the x squared, we need to square x. So 81x squared is 9x in parentheses squared. If you want to think of it as the square root of this, that's fine too. And then 49 is 7 squared. So this is going to factor into first parentheses, 9x, plus second parentheses, 7, times first parentheses, 9x, minus second parentheses, 7. Next up, we have 2x squared minus 18. Wait a minute. We need to check for a greatest common factor. I can tell that both of these are divisible by 2, so I'm going to factor a 2 out front, and that's going to leave me with x squared minus 9. Well, x squared minus 9, that's x squared minus 3 squared. So I'm going to leave my 2 out front, and then the x squared minus 9 is going to factor into x plus 3, x minus 3. Finally, we have 3x to the 4th minus 27. My greatest common factor is 3. And if I factor out a 3, I'm left with x to the 4th minus 9. So it's not an x squared this time. So I need to check to see if I can write this in the same form as I have been as something squared minus something squared. Well, we know that 9 is 3 squared, so we just have to figure out this first set of parentheses. I'm aiming to get x to the 4th. So what I need in here is x squared. Because if I take x squared times x squared, I get the x to the 4th. So I need to leave my 3 out front, but then I'm going to have x squared plus 3, x squared minus 3. That's how we factor our differences of squares. I have one more difference of squares that I want to look at because it's a little bit different. We're going to look at x to the 4th minus 16. You might not see what makes it different yet, but that's okay. We're going to see if we can write it in the same form, the something squared minus something squared. Well, we said last time that x to the 4th is x squared squared. 16 is 4 squared. So that means our x to the fourth minus 16 is going to factor into x squared plus 4, x squared minus 4. You might be saying to yourself, well, I don't see what makes it all that different. The problem here is that we're not done. Generally speaking, if you're asked to factor something completely, I'd say probably about 70% of the time, you're going to be able to factor after you've already factored once. In this case, we have an x squared minus 4 here. That is also a difference of squares because it can be written as x squared minus 2 squared. So I need to factor that expression even further. I'm going to leave my x squared plus 4 out front, and then my x squared minus 4 is going to factor into x plus 2, x minus 2. That is the answer we're looking for. So we need to check along the way to make sure there's nothing else we can factor. You might be asking yourself, well, what about this x squared plus 4? And that's not a difference of squares because it's not a minus sign. When we use subtraction, we call that a difference. This one is a sum of squares because there's a plus. Well, factoring sum of squares. Hate to tell you, sum of squares, they don't factor. There's nothing we can do with this. We should check for a greatest common factor, but it's only 1. There's nothing I can do with this. So when an expression cannot be factored, it is prime. Similarly to how we have prime numbers, such as 5, the only way we can multiply and get 5 with positive integers is 1 times 5. The only way I can multiply 2 polynomials together and get x squared plus 1 would be 1 times x squared plus 1. That's what makes it prime. There's no way I can break it into smaller pieces. There's one more type of factoring we're going to look at, but I'm not going to treat it any different than some of the factoring techniques we've already learned about. We are going to be looking at perfect square trinomials. Now, perfect square trinomials have a special property to them, and I'll show it to you, but in my mind, it's not important enough for you to memorize. So we're going to look at 4x squared plus 20x plus 25. First up, we want to check for a greatest common factor. These two are both divisible by 4. These both are divisible by 5, but the only thing they all three have in common is just 1. So it looks like we have a trinomial where our a value is not 1. So that's when we need to do our factoring by grouping, or the AC method. So we have 4x squared plus 20x plus 25. If I take my a value times my c value, 4 times 25, that's 100. So I need to make my t-chart based on 100. So I need two numbers that multiply to give me 100, but add to give me 20. That's going to be 10 and 10. So what I need to do is take that 20x in the middle and break it into 10x and 10x. I need to bring down my 4x squared and my 25. Break it down the middle. 4x squared and 10x have a 2x in common, which would leave me in parentheses with 2x plus 5. 10x and 25 have a positive 5 in common, which would leave me with 2x plus 5. Cool. So it looks like we have the 2x plus 5 in common. And if I factor out the 2x plus 5, I'm left with 2x plus 5. That is what makes this a perfect square trinomial. I can rewrite this as 2x plus 5 quantity squared, because it's 2x plus 5 multiplied by itself. if you can learn the pattern of this, it simplifies to a plus b quantity squared is equal to a squared plus 2ab plus b squared. But if we can factor them the same way we've been factoring trinomials where a is not equal to 1, I don't deem this necessary. If that's something you want to look into, feel free to be my guest, but I am not going to require you to memorize that this is a formula in and of itself. For the second one, the only difference is that we have a minus 20x. So if I go to factor this one, 4x squared minus 20x plus 25, my a times c is still 100, but this time I need my factors to add to give me a negative 20. So what I need are a negative 10 and a negative 10. So if I break my negative 20x into a negative 10x and a negative 10x, bring down my 4x squared, bring down my positive 25, break it down the middle. 4x squared and 10x, they still have a 2x in common, but in parentheses we'll be left with 2x minus 5 in parentheses. I need to factor out a negative this time because it's the first sign after the dotted line. We still have a 5 in common. That will leave me with 2x minus 5 in parentheses, and now you can probably see we're going to have 2x minus 5 times 2x minus 5, which we could also write as 2x minus 5 quantity squared. So that means there is also a version of this formula with a minus sign. A minus b quantity squared is equal to a squared minus 2ab plus b squared. Again, if you want to memorize that formula, be my guest, but I do not deem it important enough for you to have to be able to use it, because we can factor away what we already know. So we have all of these different factoring techniques. Let's see if we can put them together. These three problems are all similar, but we're going to get some different answers flying around. First up, we have 18w plus 50. First thing we need to check for is a greatest common factor. Both terms are divisible by 2, so I'm going to factor out a 2. That's going to leave me with 9w plus 25. So we need to check if 9w plus 25 factors. It is a binomial, and the only binomial we know how to factor is a difference of squares. It has a plus sign, so we know it's not that. We're done. 18w squared plus 50. I can still factor out a 2. That leaves me in parentheses with 9w squared plus 25. Again, we can only factor a difference of squares when we're looking at binomials, and there's a plus, so we're done. This last one, we have 18w squared minus 50. So that'll be 2 times 9w squared minus 25. That is a difference of squares this time. So we want to write it as something squared minus something squared. I can write the 9w squared as 3w quantity squared, and 25 is 5 squared. So I need my 2 out front. We get 3w plus 5, 3w minus 5. So that puts everything together. So we have all of these different ideas for factoring. So what I did was I put together, I found on Google a really nice factoring flowchart, and it tells you what you need to check for. And I crossed out the stuff that we're not focusing on. So if you are asked to factor an expression, you start by factoring out the greatest common factor. Every single time. Then you decide what type of polynomial are you looking at. A binomial, meaning you have 2 terms. A trinomial, meaning you have 3 terms. Or a polynomial with 4 terms, which they don't have a special name. Sorry. If you have a binomial, You need to check if they're perfect squares. If it's a difference of squares, it's going to factor into a squared minus b squared as a minus b, a plus b, or we wrote it as a plus b, a minus b. We have the example of x squared minus 16 here. If it is a sum of squares, it does not factor. If it does not factor, we say it is prime. We are not focusing on perfect cubes in this class. Yes, you can factor them, but that's just not something we're going to dive into. If you have trinomials, then if a is equal to 1, we get to go the easy way. We set up our two sets of parentheses with x's in front. We find the two numbers that multiply to give us a times c, but add to give us b, put them right after the x's. That's all there is to it. If a is not equal to 1, we use the AC method, or we talked about factoring by grouping. We take a times c, find the number, multiply to give us b. We put those two numbers in and break up that middle term, and then we factor by grouping. And factoring by grouping is how we factor with 4 terms. Factoring is just going to take practice. There is no question about it. So make sure you're really trying to figure out when to do what steps, why you're doing the steps, and make sure you're always checking your answers by multiplying back through.